All right, so welcome back, everyone. And so this will be the first workshop for our course. Essentially, what we will be doing in the workshops would be practicing what we've learned in the lecture. So the best way to learn physics is to do physics. Look at problems and learn how to solve them or how to approach and analyze such problems. So the worksheets will always be available on stream ahead of time. So the first worksheet, it's already on stream, and if you've accessed it, if you haven't accessed the worksheet, so let me just share. So you can find it on stream. It's in week 1. If you scroll down, you'll see there the folder for our lecture slides. This will also be where the lecture recordings will go in. And then you scroll further down, you see the workshop here. So you can read the workshop on stream, or you can download the PDF of the workshop. And then immediately after our workshop session, the solutions to the workshop problems will appear here. It's also in the same place where you can find the workshop worksheet. It will just appear beside that immediately after the workshop session. Right, so the first workshop, share my screen again. Right. So the first workshop looks into units and then distance and displacement, as well as some questions about timekeeping. So the question about units is sort of just getting you to think about what the appropriate unit should be, and then about the magnitude of things. Like when you're looking at physics problems, sometimes it's useful to think about whether the answer you got is logical. So say if you're being asked the third question, for example, the diameter of a red blood cell is approximately 10 something. Does it make sense whether it's 10 meters or 10 centimeters or 10 micrometers? So just getting you to think about sensible units and magnitude of things. And then the second question is learning more about the difference between distance and displacement. And then there will also be a question about speed and time, working out the relationship between speed, distance, and time. So usually what we will do in the workshops, I'll give you some time to go over the worksheet, maybe about 20 minutes, to try and work out the problems in the worksheet. And then we will look at the solutions. We'll discuss how we'll work through the solutions of the problems. So of course, while you are working on the problems, feel free to ask questions. You can pop it in the chat box or ask directly. Unmute yourself and ask directly. Or if you're sort of unsure about your question, you don't feel so confident, and you don't want to ask your question with the whole class seeing your question, you are also welcome to private message your question to me, and I will answer your question, of course, not referring to who asked that question, but giving a general answer to that question. Right, so yeah, so have some time to look at the problems, think about them, maybe start working on the solutions. And then I'll be here to answer questions. And then after, so at 10:30, after about 20 minutes, we'll look at the solutions. All right. Does that sound okay? Does that sound good, like a good plan? All right, good. Cool. good. Thanks for the feedback. It's hard to not have any feedback. I'm not sure what's going on, but thank you for the feedback. It's good. Yeah. All right, so let's look at the first question on units. Over a 100-meter race, Usain Bolt sprints an average speed of approximately 36 blah blah. So we're wanting the unit for speed. So one of the important skills that will be useful would be the process of elimination when you're given a multiple choice question, because the format of the test and exams would be multiple choice. So let's do the process of elimination here. So obviously kilometers is not the unit of speed, so it's the unit of distance. And meters per second squared, you have their meters, which is the unit for distance, and seconds, which is the unit for time. But then you have this square, and that's not the unit for speed that we just learned. We will actually encounter this unit in the next lecture, but that means it's not the answer for this question, which means that kilometers per hour would be the unit for the average speed. Yeah, it's not the standard unit, because standard unit would be meters per second, but it's still distance divided by time units, so kilometers per hour. So 36 kilometers per hour is roughly 10 meters per second, which means over a 100-meter race, Usain Bolt sprints that in just 10 seconds. Right. Okay, so the next question: at its top speed, a cheetah can cover about 330 meters in only 10 seconds. This gives a top speed of approximately 33 something something. So top speed, so we're again looking at the unit for speed. So that automatically eliminates choice C. Seconds per meter is obviously wrong. It's not the unit for speed. We have kilometers per hour, that's a unit of speed, and so is meters per second. But 33 here fits the units meters per second. So 33 kilometers per hour doesn't really fit the given values for the distance and time, and therefore the answer will be 33 meters per second. Okay. And for the last question, getting a sense of the magnitudes of things, the diameter of a red blood cell is approximately 10 something something. So obviously 10 meters for a red blood cell, like the diameter of a red blood cell, obviously 10 meters is too big, right? It's almost as big as a building. So A is obviously a wrong answer. Now centimeters, if you think about 10 centimeters and you get your ruler, 10 centimeters is about this long, right? So red blood cells having a diameter of 10 centimeters doesn't make sense, right? Because we have veins that are very small. So a 10-centimeter red blood cell won't fit into a small vein. So obviously centimeters would also be the wrong choice, and micrometers. So even if you're not familiar with the unit micrometers, because it has this prefix micro, which the prefixes centi and micro, we will learn that in lecture 3. Yeah, micrometer is 1,000 of a millimeter. So that sort of makes sense for the unit of red blood cell. Okay. Right, for the second question, okay, I'll just look at the chats and there's some question here. Second, what's your velocity? Yes, so the second part, when you're being asked to find the velocity in each part of your journey, you calculate them separately. So the first instance, when you walked from your house of residence to the point where you realize you forgot your notebook, that's one segment. And then the second segment is when you went back. Third segment was when you started walking to the lecture theater again. Started jogging to the lecture theater again halfway, and then changing to walking halfway. That's the fourth segment. Right, so we're already in that question. So let's just look at this question now step by step. It will be useful usually when you're given worded problems like this, especially if you're a visual person. It's useful to draw the scenario. So let's draw that. You're starting from from the halls of residence or your house where you live, and you're walking towards the lecture theater. Okay, and the distance between these two places is 1,200 meters or 1.2 kilometers. I'm using meters here because it's important to have consistent units. So if your speed is stated in meters per second, your distance has to be in meters and your time has to be in seconds. Everything has to be consistent in terms of units. Okay, so the first segment of your journey, you started from the halls of residence and you started moving towards the lecture theater at the velocity of 1.5 meters per second, positive towards the lecture theater. And it took you about 240 seconds. You were walking for 240 seconds or 4 minutes before you realized that your notebook is not there. Okay, so let's say that's the first segment of your journey. And so you jog back. At a faster pace of 3 meters per second. Okay, we don't it's not given how long you jogged for. It was just given that you jogged for 3 meters per second at the rate of 3 meters per second, going back to your halls of residence. And then you found your notebook. So that's the second segment. And then you found your notebook and jogged back, starting to move again towards the lecture theater, again with a speed of 3 meters per second. Okay. And you jogged halfway. So that means you jogged for a distance of 600 meters, half of 1,200 meters. And then, so that's the third segment. And then finally, you walked the rest of the way, halfway up until the lecture theater. You walked at the speed of 1.5 meters per second over a distance of 600 meters. So that's the fourth segment of your journey. And you've indicated everything that's been given in the problem. Okay, so now let's look at the questions. How much distance do you travel overall in your walk or run to the lecture theater? So that means you have to consider all the segments of your journey, your initial walk, then your jogs and walk in and jog and walk again. So you have to add up all the distances in each of the segments. The question is, for the first segment, you're only given your speed and your time, okay, or velocity, if you want to put in the direction. You're given the speed and the time. You have to work out in the first segment of your journey. You have to work out how far. Let me just, how far you traveled after 240 seconds, which was the time when you found out you forgot your notebook. If your speed is 1.5 meters per second. So you have to figure that out in order to figure out how far you've traveled in the first segment of your journey. So there's some useful information here given. The equations for speed. Well, this is velocity, which is displacement over time, but you know that speed is distance over time. And we also rearrange the equation for you because we will learn about rearranging equations in lecture 3. So for this workshop, we rearranged this equation for you. If you wanted to find the distance or the displacement, then you multiply the velocity with the time if you're wanting displacement, or multiply the distance with the time if you're wanting speed. Okay, so we know how to find the distance. We need to multiply the speed with the time. So your speed was 1.5 meters per second over an interval of 240 seconds. That will give you a distance of 360 meters. So that's the distance for your first segment, 360 meters here. Which means that in the second segment, when you went back to your halls of residence, you also traveled 360 meters, okay, the same distance. So the total distance, therefore, is just adding up the distances in each of the segments. So the first segment, we've worked that out to be 360. The second segment is just going back to the halls of residence, so which is another 360. And then the third segment, you jogged halfway, so that will be 600 meters, and then walked the rest of the way. And that should give you 1,920 meters. Okay. Right. Good. Any question about that? Right. Okay, so let's now go to the second question. Assuming positive displacement is measured towards your lecture theater, which we've been assuming so far, with 0 representing your starting point, what's your displacement for each of the segments? So when you stop and turn back, so it's this first segment here, which we already worked out. Because you're walking along a straight line, your displacement will be equal to your distance. As we can see here also in the drawing, you are 360 meters away from your halls of residence at the instance when you realize you forgot your notebook. So here, okay, 360 meters, you can just put positive or just leave out the plus sign if you want. Right? Or you can say 360 meters towards the lecture theater. So at least you need to put some indication of direction there because we're looking for displacement. So when you are back at the halls of residence, you're back at your original starting point. And so therefore, your displacement when you're back at the original starting point will be 0. And when you eventually get to your lecture theater, displacement is just the final position minus the initial position. So it doesn't matter whether you went back and forth throughout your journey. You're just going straight. It's as if you're just going straight from your lecture theater to, from your halls of residence to your lecture theater, giving you a displacement of 1,200 meters. Yeah. Good. Is that okay so far? Yeah, right. Next question, what's your velocity as distinct to speed at the different parts of your journey? Yeah, so this was the, I think, the question. Just looking at the, yeah, all right, okay, no questions there. So so for the first segment, for your first walk, right, the problem stated that you were walking at 1.5 meters per second, and you're walking towards the direction of the lecture theater, and towards the lecture theater was indicated to be a positive direction, or towards lecture theater, towards the lecture theater. And this is given information in the problem, right? And then you jog back, right? When you jog back, so it was also given you jogged at 3 meters per second, but it also said that going back to your lecture theater will be the negative direction. So you can put a negative in your answer. The negative will account for the direction that's required. So negative 3 meters per second will be sufficient to answer the question. Or if you want, you can explicitly say negative direction or towards the halls of residence. So give some indication of direction because we're wanting to find the velocity. Okay, so for the third segment, when you jog forward, okay, it's the same jog 3 meters per second. So you can just put positive 3 meters per second, and that accounts for the direction. And then finally, you walked halfway. So for the second walk, you walked at the same pace as your initial walk. So that's 1.5 meters per second. You can also just indicate positive 1.5 meters per second to indicate the direction. Or as what we did here, explicitly say towards the lecture theater, or indicate some direction. Right? Okay, so those are the velocities. It's important to put directions when you're talking about velocities. Right. Does that make sense? Good. Yep. Good. Yes. All right. So let's move on to the next question, which is drawing a graph. So I've pre-populated a graph here because I'm terrible at drawing. We always make a joke like physicists draw stick figures and biologists draw beautiful animals. Yeah, anyway, so so you want to draw the displacement as a function of time, which means on your horizontal axis you'll have time in minutes. So you draw your graph. This is your horizontal axis, which is time. We specifically indicated minutes just to deal with smaller numbers. If we're dealing with seconds, it will be hundreds of seconds, whereas for minutes, it will be less. And on your vertical axis, you have the displacement. So you have the vertical axis here. Yeah, it's good to label your axes so that you'll know what quantity is in which, and then put the unit as well, indicate the unit that its displacement is in meters, time is in minutes, and your graph. So the problem says your graph should start at the displacement of 0 at time 0 minutes. So this will be your starting point 0. Okay, so to be able to draw the graph, you will need to find the displacements and the times for each of your segments. Okay. So for the first segment, the first walk, okay, we already know it's given in the problem that the time is 4 minutes, because you walked for 4 minutes before realizing you had to go back. And then we've worked out the displacement earlier to be 360 meters. Yeah, we worked that out in the second question. Okay. Right? So we have that information for the first segment. So for the second segment, okay, when you jog back to your lecture theater, how long did it take you to jog back? You don't know that. Okay. Right? So we still need to find that out in order to draw the graph. But we already know the displacement. So when we jog backwards, we had the displacement of 360 meters, okay, relative to your to your position after the first segment. So you went back 360 meters negative towards your lecture theater. So we have to figure out how long it took you to go back for your notebook. And we know that the velocity is negative 3 meters per second when you jog back. And again, the useful information gives you some equations. You want to find how long it took you. So to find the time, you have to know the displacement and divide that by the velocity. Okay, so to find the time, right, the displacement is negative 360 meters divided by the velocity, which is negative 3 meters. Okay. Right, so I'm including the negative signs because we're talking about displacements and velocity, and that will then give us a positive time of 120 seconds. Okay. If in some instance you forgot the negative sign in one and you end up with negative time, you already know time should always be positive, so just disregard the negative sign. Okay, so the time it took you to go back is 120 seconds. 1 minute is 60 seconds. So this means that it took you, my pen's not working. So it took you, just don't know why my pen stopped working. Two minutes, right, to go back, right? And then for your third segment, jogging forwards, again, you don't know how long it took you to jog halfway towards your lecture theater. So you know your displacement is 600 meters relative to your second starting point, which is the halls of residence, but you don't know how long it took you to jog back that 600-meter displacement. So again, you need to find the time. You know that your velocity is 3 meters per second. You're moving towards the positive direction. And your displacement is equal to 600 meters. So you can work out the time. Okay, the time is displacement over velocity. So 600 divided by 3, that will give you 200 seconds. Okay. Right, 60 seconds is 1 minute, so 200 seconds is roughly about 3 minutes and something. If you want to be exact, that's 3.3 minutes. Right, and then finally, for the fourth segment, You again don't know how long it took you to reach your lecture theater, but you walked the rest of the way. So that's a displacement of 600 meters relative to your starting point at segment 3 when you stopped jogging. And you walked with a velocity of 1.5 meters per second. Okay, towards the lecture theater, so that's positive. And your displacement is 600 meters. So you can work out the time it took you, that 600 meters divided by 1.5 meters per second. And that's 400, yeah, just double. 400 seconds, and you can work out, you need to convert that to minutes, and you can work out that 1 minute is 60 seconds. So 406 seconds is roughly almost 7 minutes. If you want to be exact, that's 6.6 minutes. Okay. So you now have all the information, you have all the displacements and all the times, and you need those to plot your graph. So for the first segment, you started from the 0 position from the halls of residence. Oh, you then need to put the numbers in your axes. So let's say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So roughly you need until like 6.6, about 14 minutes, 11, 12, 13, 14. Yeah. Okay, minutes in the x-axis, and the y-axis is the displacement. So let's put that in multiples of 100. So let's say 100 meters, 200. So you're free to choose the interval that you want to use in your scale. $500, $600, $700, $800, $900, $1,000, $1,001, and $1,002, $200. Oh yeah, you're right. 16, yeah, about 15.5. So I need one more minute there, about 16 minutes in total. Okay, so now we have our graph set up. Let's now plot the journey. In the first segment, it took you 4 minutes. So 4 minutes to reach a displacement of 360 meters, which is roughly about here. Yeah, we'll just estimate that to be about there. And 4 minutes. So that's your data point. That's your position after 4 minutes. Right? Okay. And that's, yeah. And then for the second segment, it took you 2 minutes to cover 300, to go back. So that's a negative 360 meters, which means you went back to your halls of residence. Your total displacement will therefore be 0 because you ended at your starting point, and that took you 2 minutes to go back. Okay, so negative 360 meters also means you're just retracing back your initial steps. So that's the second segment in your journey. Okay, and then the third segment took you about 3.3 minutes, and you traveled 600 meters. So your displacement after 3.3 minutes is 600 meters. So 600 meters is here, 3.3 minutes, 1, 2, 3, about here, 9.3, and 600 is here. Yeah, so that's where you are 3.3 minutes after you've started jogging towards the lecture theater, right? Okay. So that's how the graph will look like now. And then for the last segment, so walking all the way from the halfway to the lecture theater took you 6.6 minutes. Okay, so that's 1, 2, 3, 4, 5, 6.6. So the 15.9, as someone said in the chat, which is, yeah, we'll just roughly say it's about here. And from midway here, it took your displacement is 600 meters, which took you all the way to 1,200 meters. Yeah. So this is your final position in the journey, right? And that's how the graph looks like. This is what happened to my sharing screen. Yep, there you go. All right. Okay, does that make sense? Are there any questions about the graph? Yep. All right, silence. I'll take silence as that's okay, and there are no questions. Yeah, it's 11 o'clock, and maybe some of you have a class or something. We haven't had the chance to go through the timekeeping question. Yeah, I'll probably give some guidance, and then I'll let you work through this question. The answers will be posted on stream, and we can go through this in the review workshop as well. But the idea here is the light and sound travel at different speeds, as given here. So you have to figure out when the sound will reach you as opposed to when the light will reach you. Given the different speeds of light and sound. And then from there, once you figure out the time, okay, so you ask yourself the time it takes for sound to reach you, traveling that 50 meters distance of the pool. That's the first question. And then you also have to figure out the time it takes for light to reach you, and then compare these two times. Obviously, you can see right away light travels faster than sound. And so light will reach you faster, but by how much? What will be the time difference between the travel of the light and sound? That will be the discrepancy that you'll have if you started timing after hearing the sound as opposed to when you started timing after seeing the flash of the light. Okay, so that's sort of how you approach this timekeeping problem. But yeah, I'll let you work on this timekeeping problem. And again, the solutions will be on stream, or we can look at this in the revision workshops. But otherwise, are there any questions about the course or the workshop or the lecture in general? No? All right, if there are no questions, then thank you very much for attending the lecture and the workshop. And it was really great to see you here. And I'll see you for the next lecture and workshop on Friday. And yeah, take care, everyone, and see you next time. All right, I'll just stop.